Okay, hello everyone. Welcome to this webinar. Thank you for joining us. This webinar is entitled Fusion 360 or Inventor. What are the trade-offs? And it's basically a quick comparison to help customers decide which product is right for them. Okay, so without further ado, let's get started. Let's just take a look at our agenda quickly. We're going to start off with a little introduction and why we're doing this. Then we're going to move on to an overview of each of the software. So we're going to do one for Fusion 360, and we're going to do one for Inventor. We're going to take a look at all their features as an overview. And then we're going to look at their modeling workflows and have them side by side compared. Okay. From there, we're going to take the next 15 minutes to look at the limitations, the pros and cons of each software. I'll then move on to a live demo. And then we can discuss lastly the whole point of this, which is which one is right for you. Okay. At which point I will attempt to answer some of your questions if you have any. So you can maybe type your questions in or maybe just wait until the end. Either way, we'll try and answer them at the end. Okay. So just a little bit about me. My name is Irshad Hanif. I'm an application engineer for the manufacturing industry with Micrographics. I have a mechanical engineering background. I have 8 years experience in industry, so I've worked in quite a bit of different industries, from automotive to FMCG, to various other things. But I've got about 2 years experience as an application engineer in the Autodesk channel, and my design experience is primarily using the manufacturing software, which would be AutoCAD, Inventor, and Fusion 360. So I'm quite in a good position to tell you the difference between Inventor and Fusion 360. Okay, so the purpose of this webinar. Well, we want to try and answer the common questions regarding the capabilities of the two software, Fusion 360 and Inventor. Reason being, they are very similar solutions, and to the layman or to the person who doesn't know, or someone who's looking to buy software, they might not know what strengths and weaknesses each one has. So people answer or have a lot of common questions I see when I go out to clients, helping them with their design needs. The second thing we want to do is we want to clear up any confusion and misinformation. People think that Fusion 360 is now the new replacement for Inventor, which is not true. They also think it doesn't have certain capabilities, whereas it does, and vice versa. So yeah, just clear up any confusion that people might have. We also want to highlight lesser known features of each software. So there's a lot of things that are included in Fusion 360 that people are surprised to see exist in there, considering it's a cheaper package. Okay. We also want to highlight other things to consider because a lot of the time people want to jump to using either Inventor or Fusion 360 without considering what else they would need to use that particular software. Okay, and the overall goal here is just to help customers understand the difference and make the right choice. Okay, so let's take a look at Fusion 360. Okay, it is indeed a 3D parametric modeling software. Okay, it is able to do sheet metal, freeform, generative design, as well as your regular solid modeling, where you have your parts and components. It does work a little bit differently from Inventor, but it is similar in the nature that it is a 3D parametric modeling. But we will discuss more on that later. Okay, Fusion 360 is cloud-based, and it allows greater collaboration between your different parties who are designing. And it also has a cloud-based platform called Teams, where you can work on different projects with different users at a time, and each one having different access. So it's cloud-based and it's designed around team collaboration in the cloud. Okay. It is catered for industrial and mechanical design. So like I said, you do have your parts and components. Okay, but it doesn't make use of separate files for parts or assemblies in that regard. It's more of an intrinsically built design workflow. So you would try to design all your parts in one and then turn them into components where you can mate and constrain. Okay? It has features where you can animate and render. Its rendering capabilities are quite superior, considering its entry-level price point. Okay, it does include simulation and finite element analysis, and it also has CAM tools, 2.5, 3, and 5 axis. So up to 5 axis CAM ability, and with the option of additive manufacturing, where we have advanced tools that you can purchase for certain credits. Okay. Now, just to keep in mind, certain of these features like rendering and additive manufacturing will require cloud credits. So that's just Autodesk's way of having you pay for the more advanced stuff. But out of the box, it does come with animation, simulation, and CAM tools. Okay, so that's basically an overview of Fusion 360. If we take a look at Inventor Professional, also a 3D parametric modeling solution. So it has solid and sheet metal, freeform and direct editing. Okay. It follows very much an assembly part workflow. So we will make use of different files, and there's a lot of data attached to those files, as we will discuss later on. So we also have design accelerators and content center. So what that means is you have standard bolts, shafts, gears, nuts, screws, what have you in your content center. Those are basically pre-made iParts that you can insert into your drawings, which makes it very easy to connect large assemblies where you have maybe 100 or 100 parts or bolts or stuff like that. Okay. We also have iLogic and rule-based design. Okay. That allows you to automate your design parameters. So if you're going to look at, we said both of these are parametric modeling solutions, but only Inventor has iLogic, which can be used to create formulas and drive your designs automatically. So you don't have to keep on designing new structures if they follow a certain pattern. Okay. Then we have BOM and materials handling, which is also what you don't find in Fusion 360. So this allows you to create a table of parts and parts list and basically classify each part as a different type. So you can say some of them are purchased, some of them are just an item, a phantom item, etc. We also have the frame generator and weldments, which you will not find in Fusion 360. The simulation and FEA capabilities, just like Fusion 360, we do have there. And we also have in the environments tab, we have limited rendering and animation tools. But again, they trade blows between Fusion 360 and Inventor. Okay, so on the Inventor Professional Standalone, important to note that there is no CAM if you just buy Inventor Pro alone. Whereas Fusion 360 out of the box comes with CAM tools. It's actually a full CAM solution on Fusion. Another thing to consider is that in Inventor, we have iProperties and data management. So there's a whole lot of data attached to each part or each assembly that you can use to pull into your drawings or manage your different revisions and versions to basically manage your parts and your added designs. Every time you make a change, you can sort of update it and keep track, especially if you have larger, more complex assemblies. Okay. Another nice feature of Inventor is that they have design, annotation, and styles management, which means that your drawings can be completely customized, and it's very much more comprehensive than what Fusion 360 has. So you would be able to change things like your arrowheads and the size of your text, and your title block can get all of the data from your iProperties. It might be very useful for some larger companies. Okay. And lastly, we have a customizable UI, which is not so in Fusion 360. And again, we have the part and assembly workflow, making use, like we said, of IPT and IAM. Okay. Let us just take a look at a side-by-side comparison just to see exactly how well equipped each software is. So if you look at parametric modeling, freeform modeling, direct modeling, from the parametric side, you can see that Inventor is more advanced. Both of them can do it. You have a parameters option in both, but Inventor is a little more advanced. And plus, if you use it with iLogic, it becomes that much more powerful. Freeform and direct modeling, they trade blows. They are basically equal, if not exactly the same. Shape optimization is basically generative design. So it can basically calculate for you the strongest, lightest way to design the part if you just give it certain parameters. Okay. Interesting thing to note there is that that may use cloud credits if you want to use generative design and shape optimization. So it will be on the cloud only for Fusion 360. Okay, simulation-wise, for FEA and simulation analysis, Fusion 360 is better, although Inventor is still good. It does have the capability. CAM tools, Fusion 360, like we discussed, comes out of the box, whereas Inventor, you would need a collection, a design collection to have CAM tools ability. Okay, drawings and annotations. Here's another difference that customers need to consider is that it's very, very basic in Fusion 360, whereas like we discussed with styles, designs, and annotations, Inventor is very much more advanced. Okay, and the last one we can see is BOM and part management. Again, very basic. You can at most get a parts list in your drawing from Fusion 360, but you can manage your entire bill of materials in Inventor. Okay, other things to consider is that both can do sheet metal, but of course Inventor is better since it is a more comprehensive tool. Plus, if you use it with, like we said, iLogic or any of the other parametric tools that Inventor has, it just becomes that much more better. Okay, surface tools, they trade blows. They are equal in that regard. iProperties, like we said, with parts and assemblies, there's a whole bunch of data. For example, stock number, part number, design by revision or version number, stuff like that. And we will take a look at this in the live demo just now. But they don't have that kind of thing, or I would say iProperties is not supported on Fusion 360, whereas it is incredibly comprehensive on Inventor. Okay. So rendering-wise, Fusion 360 does have a newer rendering engine and better capabilities, but Inventor does have in the Environments tab a Inventor Studio where you can render your images as well. Okay, and the last two things to consider is actually more personal to the company that you're or the individual, and it considers your skill level. So if you have to remember that the learning curve for Fusion is very small because it's completely redesigned and simplified, whereas Inventor, it would take you a couple of months or years to completely master. Okay, and the cost. So if you're a small startup company, Inventor is the larger cost, and it will set you back a little more. It's a bigger investment to make overall. Okay. Just a little note there, like we said, certain things like rendering do require cloud credits. So if you want to use the advanced rendering tools, it will require cloud credits. And basically that uses the power of the online computers instead of your local machine to render something better. This will give you a much more sharper or detailed image in a shorter space of time. Okay, so let's take a look at it. The advantages of Inventor Professional. We're looking at design automation, added environments, realments, mold design, BIM exchange. That means you can interact with Revit and Navisworks and basically all your build products. You have iLogic, you have frame generator, a standard library or content center of parts. You have large assembly of tools. You have large assembly tools, and you have table-driven design, or what is called iParts. Okay, the advantages of Fusion 360, it's cloud-based, so it's easier to manage all your data between people working remotely. It's easier to design less complex parts because it's a completely different workflow. Okay, it comes out of the box with a full CAM solution. It has an effective simulation and FEA analysis. It caters to a lower budget. It has rendering and animation, which is slightly superior to Inventor, and it has Apple Mac support. So if you own an Apple PC, Inventor is not available, but Fusion is available on Apple PCs. So just some things to consider there. Okay, now you would have heard me talking about, well, certain things aren't available on Inventor standalone. Well, that means something like CAM is available on the cheaper Fusion 360, but if you buy Inventor as a standalone package, you won't find it. So the option there would be to buy, if you do need Inventor and you need CAM, the option there would be to buy a product design manufacturing collection, which includes both Inventor and Fusion 360. And we can take a look at just some of the highlighted products in this little graphic here. Okay, so like we say, it includes Inventor and Fusion. It includes Inventor Nastran, which is a much superior simulation solution as compared to Fusion or Inventor CAM on its own, Inventor FEA on its own. It has 3ds Max, again, a much superior solution for rendering. It has AutoCAD 1. AutoCAD 1 is basically just the name given to all of the AutoCAD products. So you can see here is AutoCAD, AutoCAD Mechanical, AutoCAD Electrical, AutoCAD Architecture, etc. Okay, and then we have Vault Basic, which is packaged in there, and that's basically a data management system. So if you really need more control over all of the parts and assemblies, and you're doing very complex things with multiple designers, Vault Basic is included in there as well. Okay, just to touch on compatibility and interoperability. So Autodesk AnyCAD technology is available on both Fusion 360 and Inventor. What that means is you can interact with CAD data from any software, be it SolidWorks, be it SketchUp. There's a whole bunch of supported file types, and you can import them as a reference model, or you can convert the model. And basically what that means is you can work with a design as a reference where if it's changed on the original software, Inventor or Fusion will understand those links and it will change in the Autodesk product. Or you can convert the model where you just get the solid shapes out and it's no longer linked to the original CAD data that you started with from the other product. So there's a choice with any CAD technology. Okay, Inventor also supports BIM exchange. So like we said, with Revit and your build and architecture solutions, Fusion does not. Okay, well, not as yet anyways. Hardware requirements. Inventor is the more taxing of the two. So you would need a beefier PC to handle it. Fusion 360 runs on a surprisingly wide range of PCs. So you don't require as powerful a PC to run it and operate it. Of course, as you do more and more complex designs, it's going to take a toll, but it works best on a mid-range PC with smaller designs. So again, you don't need to invest so much in your hardware with Fusion 360 as compared to Inventor. Okay. Maybe now it's time to do a little live demo. So we can take a look at, we'll do a little UI tour of Inventor. And then we'll just discuss all of these extra features that we can see here. We can see parts, assemblies, and file types. We'll discuss parameters and eye properties. And I'll show you the eye logic, the content center, simulation, and drawings. And then we'll contrast that with what's on the right-hand side. We'll do UI tour and show how they're different between the two software. Okay, so let me just open up my Inventor. Okay, so this is what Inventor looks like. You'll notice that you have your ribbon and your tools up here. You are able to use, so if I go to a new drawing, I'm able to choose from some of my templates. So I have parts, assemblies, DWGs, and presentation files. So like we were discussing, it very much makes use of the part IPT, IAM, and DWG workflows. Okay. And whereas Fusion doesn't make use of that at all. Okay. What we can also notice is that in your drawings, you have a whole array of styles to choose from, and you can edit your design the way you want to. And that will be from your styles editor. And you can basically customize your drawings the way you want to see them. Okay, I'm just waiting for the window to pop up. There we go. Okay, so like if you can see in this example, you can see our drawings is very customizable. We have each aspect, for example, your dimension line, your text style, your title block, and all of these can be imported from your iProperties. So if you look at your parameters here, you can say it's drawn by whoever, it's checked by, and those come from the part itself. So if I show you the part, we can look at our iProperties, and we can say, right, these are all the data that's attached to a particular part or a particular assembly, and those can be pulled in different things. For example, your drawings. They can also be used in iLogic, which is where you take some of the parameters. Okay. You take some of the parameters and you can use formulas in here to drive them using rules and logic-based design. So that's another benefit of Inventor. Okay. Another thing is iParts. So we have this particular handle here. We can take a look at multiple versions. So we can say that we can do a little table. Oops, I've clicked the wrong thing. So basically, this is what we refer to as table-driven design, where we can set a little table of parts that will drive each different series of the part in a family of parts. Let me just show you an example of what I mean. So for example, I have 4 different variants of the same part, and I can choose from a different set set of parameters of each of this part. For example, this part has a length of 200 and a diameter of 15, whereas the next one, you can see the length is longer. And if I change between the two, you will see that is now moved to the next one. So this is what helps you design a family of parts quite easily, all in one, without making separate parts and having a very complex data set. Okay. You can also look at our content sender. So for example, let me just delete those and I'll show you. So a content center, like we discussed, is a set of tools we can place from our content center. And it's basically a preset list of iParts that you can come in and insert to your designs like so. Okay. And you'll see that it has tools like autodrop rather, where it fills in the bolts and nuts, and you have a whole library of parts to choose from, and you can automate your design that way. So you will see here that you have a lot of different parts in here. You've got everything from bolt, you've got fasteners, you've got shafts, you've got sheet metal and structural shape, you've got tube and pipe. So there's a lot of standard fittings here and they work in the same way. They will detect the size when you hover over the part and insert them automatically with the correct mates and joints. So it makes things very easy. This is something you don't get on Fusion. Okay. Then you also have your rendering environment and your stress analysis. So you can go into a stress analysis and perform on a single part any stress analysis, and you can create a study. This, like we said, exists in Fusion as well, but it's just a little bit, I would say, well, they are equal, although like we discussed, they do trade blows. Okay, then we can look at, you will notice that in this particular version of Inventor, as a standalone, it does not include any CAM tab here because there is none. However, if you do purchase a PDM collection, you would notice the CAM tab in there. And up here, you will see that I have a CAM tab. Okay, and this will allow me to do all of my toolpaths and my post-processing, my G-code from Inventor. So again, this is only available if you purchase a full PDM collection. Okay. What we just want to preview here in this particular example is, I'm just gonna is iLogic. So for example, we have this little model here, and iLogic is a really powerful tool because it can help you automate your design, and it does it by creating parameters and rule-driven based logic. So we can take a look at, for example, we have a form here to drive this little box. Okay, so we can maybe increase the depth to maybe 800. And you'll notice that the length of the runners here will adapt accordingly because I've inserted a particular length. Also, if I increase the height, you'll see that the number of dominoes in here have now increased because it is parametrically driven to calculate how many dominoes it should put depending on the height. So iLogic is very powerful when you want to automate your design. Okay. Also, you can have things like where you can turn on or off the certain features, like so, and perhaps change the thickness of your panels, like that. Yeah, like I said, so very much a tool for automating your design. Okay, just to show you a preview of what some of the rules look like. So we can set up rules, and it uses a Visual Basic type programming. So you can use logic like so and type in your if, then, or statements, and it will run according to what you've set it up here. Okay, so that was a little preview of Inventor's capabilities. Let's now take a look at, let me just swap you over to our screen. So we're going to take a look at a UI tour of Fusion 360. And then we're going to go through its way of working, show you its parameters, CAM, simulation, etc. Okay. Let me just open up Fusion. All right. There we go. All right. So this is what Fusion 360 looks like. And you'll notice that it's very much different or slightly different to Inventor in that it separates each section into what's called workspaces. So you have design, where you'll actually do your modeling. You'll have a manufacturer where you'll come in and do your CAM, and you'll have drawing, where you can actually do your drawings and annotations from given designs. However, so for example, you'll notice that the design tab is very similar to what you have in the 3D model tab in Inventor. So if you look at this, or rather this, in your 3D model tab, you've got the same tools here. So very similar, and you can achieve the same things for the most part. However, things look a little bit different when you go onto the drawing tab. So if you go into the drawing, and I have one open here already, you'll see that it's much more limited. There are no styles. There are very little parameters or eye properties that you can pull in. And it's just completely limited as compared to the Inventor's drawings. Okay. The other thing we need to show that it is different is the projects. So if you look at our workspace, like we said, Fusion 360 is completely cloud-based. So you'll basically work by creating projects. Okay, you open those projects, save all of your data here, and it does not make use of separate IPTs or IAMs. You'll basically draw your parts and create multiple bodies or components and constrain them the way you want to. So, for example, if we can take a look at let me see if we have an example. We should have something here. I'm just going to open some demo I did. Okay. So like we said, we can create, you'll notice that they have each separate component in the design, although it doesn't save it as a separate file. It's all one f.3d file, Fusion 3D file. So no IPT and no IAM. And you can do sort of the same constraints and designs as you have in Inventor. Okay. So you can see that I've created some relationships between the two, revolving and aligned along the cylinder here. And those will have you create your drawing styles from there based on the position of these. Okay. What else will we? Okay, so we also have in the manufacturing workspace, we have a CAM solution. Like we said, this is a full CAM solution equivalent to what you would get in a PDM collection. Okay, and it can do all sorts of your 2D and 3D toolpaths. Okay, it's fully capable of doing G-code, so you can output your G-code from here as well. And I can just show you. Oh, well, I don't need to show you any of that. You can see that, let me just go to manufacturer. Yep, you have, like we said, your 2D and 3D adaptive. We discussed that it goes all the way up to 5 axis. You do have what you'll see this little plus here. These are additive manufacturing solutions, so you can have these. These are included for a limited time right now, but they will require cloud credits. So you just be aware that if you want features like hole recognition, and there's some other ones that I cannot remember where they are. Ah, there we go. There's a tab here where you will see the little plus on the little icons that are additive. Okay. Some of them are here. You also have probing capabilities, just like Inventor, so you're not short of anything in Fusion 360's CAM. Okay, then if we go, we also do have in your design tab, again, we do have parameters, which are, well, I can't show it to you here. I have to show it to you here. So we do have parameters, so you can drive some of these things via tables and formulas, just like Inventor. However, it is not as comprehensive as Inventor. Okay, so that's basically it with Fusion 360. Let's just go back to our PowerPoint. Okay, so after seeing a little demo of each one, we have to ask which one is right for you. Well, there's a couple of questions that you need to ask if you want to decide which one to choose. And we'll go through each of these questions. You're going to firstly ask, how large are your assemblies? Obviously, Inventor is catered for more large assemblies, and Fusion 360 is more for smaller, less complex assemblies. So you might ask which one, or rather what defines large and what defines small. Well, according to Autodesk, less than 500 parts should count as on the smaller side, whereas anything above 500 parts, you would typically be looking at Inventor. Okay, what features do you require? Okay, so do you require automated designs? Do you do a lot of frames or sheet metal, or specialize in different kinds of products, or do you just do one product? So the different features in each package will play a role there. Okay, how advanced or how complex are your designs? So do you have a lot of manual labor, or can you automate it using iLogic? Okay, which brings us to our next point. Do you require design automation, or do you have a large enough team to do all of your drawings manually if you prefer it? Also, what are your drawing and BOM requirements? You've got to remember that Fusion 360 is very limited when it comes to drawings and annotations. You don't have the full style and design library that you do with Inventor. So you also cannot do drawings from scratch. So sometimes if you do need that, for example, if you want to draw layouts, you would probably want to use AutoCAD or AutoCAD architecture for that to draw a layout of your factory, because neither of these solutions can do drawings from scratch very effectively. Okay, then what are your simulation requirements? In this case, both software packages will suit your needs because they both support FEA and complex simulation. However, if you need something more advanced with dynamic analysis and such likes, you would probably be looking at a PDM collection where you have Inventor and Astra. Okay, what are your CAM requirements, or do you need it at all? If of course you don't need any CAM, let's say you have a third-party CAM software, you could probably just get a standalone Inventor. That might work for you. Whereas some of our customers buy Fusion for the CAM functionality alone. I mean, they're drawing an Inventor, but they want a CAM package, they just get Fusion 360. Then you also got to consider what is your current skill set and what is your current budget. Those are technically important to most companies because we're all trying to save a little money and we're all trying to not put too much expense or too much pressure on people to learn a large set of things in a short space of time. It might be that you purchase Inventor and you're not using half the features because the guys who are doing the drawings aren't as skilled as yet. Okay, so we can take a look at some examples of how you're gonna, or how companies would choose. So we can take a look at case one where, for example, you are a small workshop and you have very simple assemblies, less than 100 parts, and maybe it's just the three of you. It's sort of like I wouldn't say a one-man band, but it's sort of like a very small workshop, and you do on contract one-off parts that you send to your CNC, and it's basically you or the three designers themselves that take it to the CNC. There's no need for automation because it's mostly one-off parts. There's no need for involved drawings because all of it is being machined by themselves. And they use maybe some FEA just to test that their parts will hold. In this case, the solution would be Fusion 360 because it ticks all the boxes and it doesn't leave them short of anything. Okay, we can look at case two, however, where we have a much larger manufacturer. So think automotive or very complex engineering industries like mining, for example, where you have large complex assemblies that are greater than 500 parts. We're looking at multiple teams of engineers and draftsmen. So they have people who actually draw, people who design. So different sets of people will be using FEA and simulation, and different sets of people will just be doing the drafting. You'll have various complex parts put together. Some need to be machined, some need to be, some are sheet metal, some are just frames to carry the designs. There could be a lot of factors to consider. And as a result of having such complex designs, you're going to need to manage them properly. So the properties, what revision it's on, has it been changed, and it becomes revision 1.2, etc. And it becomes very important to identify by stock number and part code, so stuff like that. In this company, for example, maybe the engineers would use advanced dynamic analysis for their FEAs, and to detect failure modes in their manufacturing. And it may consist of a bunch of highly skilled workers. So like we say, very advanced or skilled engineers that know exactly what they want to do, and they've been working with CAD software for quite a while. And they might want to do extra plant layouts and machine detailing for each new product that they make. So, machines might need to be moved to cater for a different product, and they will have to draw layouts. Well, the answer here, the best solution we would recommend is a PDM collection. Reason being, like we say, it's going to include Inventor. It's going to include Fusion as well. So different people, if each of the skilled workers has a PDM collection license, they can use the software they prefer according to their skill level. They can also have both advanced or standard FEA analysis. And they will also get to use AutoCAD, which will allow them to do plant layouts and machine detailing, right? And then we have a third case where we have sort of a medium-sized enterprise, okay? And maybe they just build not so complex parts as case 2, but they build a single type of product, perhaps gearboxes, and their parts will consist of between 100 and 500 parts in their assemblies. Okay, you look at a semi-skilled team, okay, and they only make the one product, so you probably can say that it's a repetitive design process. So some automation is needed if they want to change something. They don't want to have to go and change each corresponding detailing. For example, if they change a diameter of a gear, they don't want the casing of the gear or the gears that it mates with to have to be redrawn. They want it to update, automatically. So there we're looking at automated design and, some sort of iLogic or iParts, that sort of thing. They need detailed drawings for their artisans. So for example, they want to send out drawings to manufacturing, but it needs to show a whole bunch of information. For example, the correct version in a particular style, in a particularly sectioned view. So you would need the advanced tools of Inventor there. Okay, they don't use CAM, and they need basic FEA, and maybe sometimes they would need some rendering for their customers. So in this case, the solution would be to recommend Inventor, simply because it offers all of the things that they need without keeping them short of anything. So like we said, it really depends on what your needs are in deciding which solution to get. Okay. And that brings us to the end of our presentation. If you have any questions, we can maybe answer them and take a look and see if we can help you answer your questions. Does anyone have any questions? Okay. I'm just going to give it a few more minutes. I can see. All right. Well, if there are no questions, we can sign off here. And thank you again for joining us for this webinar. And I hope you got a little bit more clarity onto the differences between Fusion 360 and Inventor to make a correct choice. All right. All right, I've stopped recording. Is everyone still there? Hello?
Hello. Sorry, man. I'm just on a call quickly, but it was a great presentation. Thanks so much.
Thank you.
Will you be saving it to all the rest of them, eh?
Yes,
Okay,
these are going to
cool.
go online. These are external, so they're going to go online. So it's fine.
Yes. Okay, great. Thank you so
Okay,
much.
thank you.
Have a
Thank
good
you.
day. Bye.
Okay, you too. Bye. Okay, guys, I'm going to end this meeting. So if any of you still here, unless you have more questions or you're really bored, all right.